This is All India Radio. In the program Spotlight, now we bring you a discussion on successful launch of small satellite launch vehicle. The participants are Dr. Anuj Sinha, former advisor, Ministry of Science and Technology, and Rajesh Lake, AIR correspondent.
Mr. Sinha, SSLV is the new small satellite launch vehicle developed by ISRO to cater to the launch of small satellites up to 500 kg in low Earth orbits. Would you elaborate on what is the importance, according to you, of SSLV?
This is a great achievement which we have our scientists and engineers at the Indian Space Research Organization have achieved on 10th February 2023. The small satellite launch vehicle capability that has been demonstrated by this launch is something that we feel very proud about. Over the past many years, the mission for this has been working with many bright engineers and scientists, working out how do you get this 34-meter tall, 2-meter diameter, 3-stage rocket up and precise enough to launch 3 small satellites in their right orbits, near Earth orbits. So there's a lot of engineering, a lot of design that is required by people at the ISRO. Second, that the people who have designed these satellites, the Earth observation satellite, EOS-07, the Janus, and the Azadi-Sat, they have benefited so much in ensuring that these very lightweight, very small, mini satellites are designed in such a way that they'll be able to complete their scientific objectives and yet be portable enough to be put onto the SSLV and taken into orbit. So there's been a lot of work which has been done.
These 3 satellites that have gone into the orbit, let us know about how this satellite, SSLV, which has been launched and it carries up to 500 kg to low Earth orbits on launch on demand basis. Now, what is this launch on demand basis? Is it aimed to commercialize the small satellite launches?
Probably in the long run, it will become commercial. At the moment, I think it is still a developmental flight that we are talking of. The developmental flight, similar one, was tried in August 2022 and it missed marginally some of its targets. To the engineers and scientists at ISRO to sit back and understand what are the shortcomings, and therefore the development flight 2, which is what this one was, with modifications, and it was able to function very effectively. So to be able to insert these satellites in their intended orbit requires a lot of precision. You have to run your engines for fractions of seconds to be able to get things in the right orbit. And that is a very precise job that when you run it for only a few decimals of a second, and then you release your satellite at that particular point. So it is some 880.1 second later you have to release a satellite, or 900.1 second and you have to release the satellite. So these are very precise calculations of what you're going to do, and you're going to control it from your control room. A lot of technology, a lot of confidence is needed to be able to do this. That is why we will be able to offer this capability for launch of satellites in future. That is what I mentioned when it's on demand. That if there is a need for 600 kg or maybe 1000 kg, we are talking about 500 kilogram low Earth orbit capability, and we have demonstrated it. Future mini, nano, and micro satellites will be probably demand. We'll be able to launch them.
The small satellite launch vehicle successfully launched 3 satellites, as we were discussing a while back, into their intended orbits. In its second developmental flight, the SSLV-D2 vehicle placed EOS-07, which you mentioned about, Janus-1 and Azadi-Sat 2 satellites into their intended 450-kilometer circular orbit with an inclination of 37 degrees. Elaborate on these 3 satellites that have been placed into the orbit. Let's talk about first EOS-07.
EOS-07 has instruments which have been designed to measure millimeter humidity sounder and to look at the spectrum monitoring. So these payloads are part of the EOS-7. It's a new experiment that is being tried, and this will help scientists to understand all these phenomena which are very, very important and with the data that is missing. Janus-1 is a technology demonstrator satellite. It is a smart satellite mission. It has payload, and they are looking at the onboard computing platform. There is digital twinning, and all this is in that very small space that Janus-1 has. So they will be observing how it functions, and if it does, it will be something very good. They are calling it a modular bus. The Azadi Sat is, of course, as mentioned, part of the 75 years of India's independence celebration, and Space for Kids, the startup in Chennai, who have been responsible for this, they have worked with 750 girls for designing the experiments, for then working out the instruments, and then for putting it all together. So there is this amateur radio communication capability, there is a measuring of radiation level in space, and then to be able to demonstrate that the satellite structure is expandable. I think these are very important objectives, and it is very heartwarming that these girls who were involved in this have done such a beautiful job that the satellite was ready in time, and it has been launched, and it is already functional.
So as you said, EOS 07 153.6 kg Earth observation satellite was realized by ISRO, and Janus-1, a technology demonstration satellite weighing 10.2 kg, belonged to Antares USA, and Azadi Sat-2, an 8.8 kg satellite, was realized by Space Kids India by integrating various scientific payloads developed by 750 girl students across India. Now, what is important here, Mr. Sinha, is that Antares USA is now piggybacking on the satellites developed by India. Earlier, we were dependent on other countries. Now, would you confidently say that India is self-reliant when it comes to satellites going into orbit?
Definitely. The way engineers and scientists have honed their capabilities with every mission that they have undertaken, something which definitely gives confidence to ISRO and to all of us that we have adequate understanding of the requirements, and we know what is it that we can do and how quickly we can do it. There are going to be benefits, international and national. I think, our scientists, our mission director, everybody involved deserves a huge round of applause for the way they have been able to do this within very limited time schedules. The moment a mission is announced, there are very strict time schedules that are put up. There are very strict resources that are issued, and the manpower has to be, therefore, probably working round the clock to be able to achieve these. And to do it, I think definitely gives a lot of confidence, a lot of pleasure, a feeling that, yes, we can do it. And that, I think, is very, very important.
Mr. Sinha, in its first developmental flight on August 7, 2022, SLV-D1 had marginally missed to place the satellites. And thereafter, our scientists implemented the recommendations made by the expert committee that analyzed the shortcomings of SLV-D1 flight, in which the VTM, the liquid propulsion-based velocity trimming module that achieves the desired velocity for the insertion of the satellite into the intended orbit, played a major role. What were the recommendations basis which the SSLV-D2 was launched?
These are technical matters, and which I'm sure they must have. We will not be able to discuss it because they are not in the public domain. But it is important to understand that in development, in research, we move from one stage to another. And if there is learning to be done, it is done and incorporated in the next stage. So the process of developing technology is this step. It is not something that you can suddenly jump a stage, just hope that it will work.
SSLV is meant to be a low-cost access to space. That means it is available from India to any and every country.
We are developing a spaceport in Tamil Nadu, which will be developed as a capacity for launch on demand satellites. And this is at Karipatnam, likely to become area of a lot of activity as far as these low Earth orbit satellites and therefore these small satellite launch vehicles. There's a lot of planning that is already happening to ensure that this comes up in time, and that will help 20 countries to be able to do a lot of experiments with these types of mini, nano, and micro satellites, which will all be, cost comes down, it is obviously shared with all the partners. And the scientists who take benefit of the data that is generated are also going to be very happy that if they are able to get this data in time, earlier the better, they would be able to ensure that its application in communication, in weather forecasting, in mapping, in agriculture, wherever, is available for use. Each of us benefits.
Now, the Union Home Minister Amit Shah congratulated the team after the launch, and I'm a quote from his tweet: "Kudos to Team ISRO. India creates history with the successful launch of the SSLV-D2 EOS-07 mission on the advent of its Amrit Kal. The launch allows India to send up to 500 kg objects in low Earth orbits, paving the way for self-reliance in space programs." And this is what we were discussing, Mr. Sinha, a while back, that how India is going to be self-reliant in all space programs henceforth. Now, two of the points that I have for you related to the self-reliance is that it has a quick, or rather a low turnaround time. So what is that, and how this program facilitates flexibility in accommodating multiple satellites?
The launch vehicle is a 3-stage vehicle with the solid-state fuels at 2 stages and a liquid fuel at the 3rd stage. And it has been designed in such a way that it is able to meet the requirements for a flight of this duration. And therefore, the ISRO is confident in saying that we will be able to do small satellite launches at more frequently. Unlike the larger geostationary launch vehicles or the polar satellite launch vehicles, which are much big and more monstrous. And the spaceport that they are developing is also for that capability, where they are able to then handle the so-called launch on demand. How many requests would be there and what will be the process of accommodating all the demands is something which ISRO and the government will work out. But it definitely augurs well for international and Indian science.
And also the fact is that the SSLV demands minimal launch infrastructure. So, as you very said, it is very easy now for us to get into the orbits or into space, also because of the fact that we discussed that it offers low turnaround time.
You are right, sir. Absolutely.
Any congratulatory note from your side, Mr. Sinha, that goes to the scientists of ISRO?
Of course. I am so proud of our engineers and scientists who have done all this spade work for days and months together to be able to come to the successful end of a mission is a feeling of great satisfaction, and my full good wishes to all of the people who are involved and their families also, because they are the ones who sacrifice a lot when the engineers and scientists spend round-the-clock time inside the laboratories and inside the workshops. There's a lot of learning that takes place. I'm sure that these lessons that they have learned, the success that they have achieved, spur them on to greater heights, and we'll be there to cheer them and look forward to a lot of good such opportunities to talk about.
Sure, Mr. Sinha, and along with ISRO, we look forward for catering to the increasing global need of launching smaller satellites into space. Thank you so much for your time with All India Radio.
Thank you so much.
You are listening to a discussion on successful launch of small satellite launch vehicle. The participants were Dr. Anuj Sinha, former advisor, Ministry of Science and Technology, and Rajesh Lake, AIR correspondent. This program was produced and presented by the News Services Division of All India Radio. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official. You may email your opinion about this program at airnsttalks@gmail.com.